Welcome to Algebra Review. This is Standard 4. This is Part 3 where we're going to talk about working with square roots and doing just a few problems to kind of finish off this section. So this is basically problem 3. Okay. There are other videos, not necessarily mine, but other people who've done videos on square roots. You might want to search on that and just get kind of an idea of some things. But what I want to go over is this idea right here, and that is I want you to see that if 3 times 3 equals 3 squared, which equals 9. Interestingly, the square root of 9 is 3. Okay, 4 times 4 is 4 squared, or 16, and the square root of 16 happens to be 4. So there's a connection between the square of a number and the square root of a number. In algebra, we use them to reverse each other. So like when we were simplifying equations, the opposite of addition was subtraction, and the opposite of subtraction was addition. The opposite of multiplying was dividing, and the opposite of dividing was multiplying. Well, we're going to find out that if you have a number squared, the way that you undo it is by taking a square root. And the way that you undo a square root is by squaring it. For example, just a little piece right here in the corner, the square root of x squared just gives you x. Okay? For the same reason that if I wrote the square root of 9 here, if I wrote it this way, in equivalent form, square root of 3 times 3, or 3 squared, the square root of 3 squared still gives me 3. Okay, so here's some of the problems that they asked us to deal with. I'm hoping that we can get these done in 10 minutes. We will see. They basically, I'm going to talk a little bit about my strategy in it, but this one has a square root, and once the square root is by itself, the opposite is to square it. So this is kind of an undoing process for me. Okay? And so what I'm going to do is I'm literally going to say, I'm going to take and square that and square that. Okay? If I square this, I just get what's underneath the radical. 1 minus 4x equals, and what's 10 times 10? It's going to be 100. Now this is not a hard problem for us, so we're going to go ahead and do it. Okay, subtract 1, and I get negative 4x equals 100. I'm sorry, 99. And I'm going to divide both of them by negative 4, like we've been doing all year. And it's not going to be, let's see, 99 divided by negative 4 is negative 24.75. I'm going to check it really quick. So I'm going to plug it in here. So I'm going to do the square root of 1 minus 4 times, what did I say the answer was? Negative 24.75. Close the square root. And let's see what we get. We get the answer as 10. So we see that that did work right. That is the correct number for that. Okay, so that's working with that square root. Okay. This one, I'm going to do what I can before I have to deal with that fraction right there. But I'm going to use a fraction busting technique in a moment. So I'm going to add 7, both sides. That's going to give me, cancel that out, 4x plus 2 over 2 equals 7 and 8 is 15. Now, lots of different ways I could do this. I could multiply both sides by 2, which is what I think I'm going to do for this problem. I could make it a fraction and cross multiply. I'm just going to multiply both sides by 2. Multiply that side by 2. Multiply that side by 2. Those will cancel out, and I will get 4x plus 2 equals 30. A little solving. And x equals 7. Okay, x equals 7. So let's see if that really does work. Okay, so 4 times 7 would be 28 plus 2. 28 plus 2 is 30. 30 divided by 2 is 15. And 15 plus negative 7 is 8. So that is right. Okay, a couple ways we can deal with this one. I'm thinking that I might want to combine these first and then maybe be able to cross multiply. So I need to make them into the same denominator, or just then something else might happen. Let's just see what we get. Let's see. I need a common number for 2 and 3, and that happens to be 6. That's kind of nice. So I'm going to multiply x over 2 times this fraction, 3 over 3. Remember that 3 over 3 equals 1, so multiplying by that doesn't change the value, it just changes the way it looks. I'm going to add that to, well, I'm going to have to multiply it times something. So I think I'm going to do 2 over 2, which is also 1. And this one already is a 6 on the bottom. So let's see what that gives us. 3x over 6 plus 2x over 6 equals 5x over 6. Next step, 5x over 6 equals 5x over 6. If I multiply both sides by 6, I will just get 5x equals 5x. And I realize that any number I put in there is going to give me the same number. I'm going to be okay. So any number works. Works for x. Okay? And that is, I believe, the end of this standard.